All right, let's take a closer look at the hypothetical situation detailed in our laboratory exercise. So we have two carts, and they're given the motion conditions set out below. We have the initial position of cart 1, the red cart, as -5 meters, the initial position of cart 2 of 0 meters. And stopping here to take a look, it looks like cart 1 is giving cart 2 a 5-meter head start. So cart 1 is going to start behind the start line by 5 meters. So it looks like their displacements aren't going to be the same since they have the same 100-meter track, but cart 1 has to go an additional 5 meters. That'll be important in just a second. So the first questions ask us to write down equations of motion for these two carts given the motion parameters. So let's do that. Let's start with our kinematics equations, and specifically I'm just going to say that my displacement, we'll call this delta x, and in general I'm just going to say delta x. I haven't specified which delta x1 or delta x2 in this case, but in general we'll say that the delta x is going to be the initial velocity in our x direction multiplied by delta t minus 1/2 a in our x direction, the acceleration, multiplied by delta t squared. And now we're going to translate this in terms of each of these parameters, which is different for each cart. So let's take a look at the first case. I have my delta x1. Delta x1 for cart 1 is going to be equal to, well, let's take a look. Do I have an initial velocity for cart 1? Yes, I do. So it looks like I do keep this initial velocity term. It's in the x direction. We just know that, so delta t. Do I have acceleration for my cart 1? And it looks like I do not. I have 0 acceleration for my cart 1. So I think we're done. This is going to be delta x1 is equal to v initial times delta t. Let's call this delta t1 just to be pedantic. So now for cart 2, the blue cart, I'm going to say delta x2 is going to be equal to, do I have an initial velocity? I don't, so I don't have this initial velocity term. Do I have, plus, obviously, I don't have negative acceleration. Do I have acceleration? Yes, I do, so it looks like I have my acceleration term. So I can say this is just going to be equal to 1/2 a in the x direction times delta t2 squared. Okay, so we have our equations of motion that's going to govern this two-cart system. So the first question is going to ask who's going to win the race given these parameters, and that's fairly trivial. Given that you're in physics, we should know how to plug in these variables and solve the equation, so I'm not going to bore you with answering question number 3. More interesting, we'll take a look at question number 4. So at what point in time are the carts going to be side by side? So said another way, these carts don't start at the same position. Are they ever going to pass one another? So one cart starts behind, we have another cart that starts ahead. One has acceleration, the other does not. Are they ever going to pass one another? Could they look side by side and see the other cart there? So this is a somewhat different question. What are we trying to solve for? Let's start there. We have our equations of motion, and what are we trying to solve for? Well, the question's asking at what points in time will the carts be side by side? So what are we solving for? We're solving for time, okay? And we're under the assumption that the time itself is going to be equal, so we're going to say this delta t for both of these is going to be the same. Okay, so let's see what else we can do. Well, I also know that my delta x initial, or delta x for cart 1 is going to be equal to, well, can I get it in terms of cart 2? That'll help me solve these system of equations. So I want to solve for t, and I have two things here that I'm trying to figure out. So let's see if I can get this x and x1 in terms of x2. And I know that it appears cart 1 has to give cart 2 a head start, so the displacement of cart 1, it looks like, has to be equal to the displacement of cart 2 plus 5 meters. It's got to go 5 meters greater. So whatever point in time this happens, the condition is that delta x1 has gone delta x2 plus 5, because it has to escape that initial handicap that it gave to cart 2. Gave him a head start. So what do we want to do? We want to solve for this t. So let's do that now, given that we now have an expression of x1 in terms of x2. Okay, so let's do that. I'm now going to substitute this into my initial equation up here and say, now I have this equation here, and I also have this equation here, so let's express this. I'm going to say that now delta x2 is going to be, rather, delta x2 plus 5, which is x1. Delta x2 plus 5 is x1. We just saw that they're identical, so I can just substitute it in. And I'm going to get something like this, is v initial times delta t. So let's compare these two equations. First, let me get another step down. I'm going to say that solving for delta x2, it's just going to be equal to nothing but the initial velocity of cart 2. Cart 1 rather, yeah. Good to specify. Catch myself there. Initial velocity of cart 1 multiplied by delta t minus 5. Okay, so now we have two equations, and it looks like these have to be equal. So now I can solve for t and figure out specifically what's going on. So let me borrow this equation from up here and bring it down here. And now we can solve for t and figure out at what point in time are the displacements going to be equal. So now we've gotten delta x1 in terms of delta x2. And now I want to see at what points in time, what values of delta t are these two equations true. So let's just plug it in and see. Plug the variables, not the numbers yet. So we have, let's start with velocity initial of cart 1 times delta t minus 5 is going to be equal to 1/2 a times delta t squared. Okay, I want to solve for t, so let's get everything on one side, and you might see a quadratic equation popping out soon. So let's move everything over here so I can get the delta t on one side. So I have 1/2 a times delta t squared. This has moved over here, so I'm going to subtract the initial of cart 1 times delta t, and I add 5. So subtract 5 from both sides, or rather add 5 to both sides, and we get minus 5 plus 5, 0, plus 5, and this is just equal to 0. So this is something trivial. We know all how to solve this from grade school. This is just the quadratic equation. So let's plug it in and see what we get. What values of t are they side by side? Do they pass? And if they do pass, at what points in time do they pass? That's the question we're about to answer with this equation that we got from those equations of motion that we derived earlier. So let's just see. So we know delta t itself is going to be equal to, so to refresh our memory, we have the quadratic equation as the opposite of b plus or minus the square root of b squared minus 4a times c divided by twice a. Okay, that's where we're going, and it looks like we have our value of a, our value of b, which is negative v1 initial for cart 1, and we have our c, which is just plus 5. So plugging everything into our new equation in terms of our variables, notice we don't have numbers yet. Don't need numbers, don't care about numbers. I want to see what the equations tell me. We'll let the equations guide our thinking, okay? So we've got our delta t. So what is the opposite of b? Well, the opposite of b is just, well, it looks like that's just plus v1 initial. Okay, plus v1 initial, or v initial 1, plus or minus the square root of b squared, negative v1 squared is just v initial 1, or negative, yeah, just v initial 1 squared. So we've got opposite of b plus or minus the square root of b squared minus 4 times a, which is 1/2 a, times our c value, which is just 5, and then we're going to divide that by twice a, which nicely here, twice a is just a itself. So we're dividing this to get our final equation, and it looks like I can do a little bit more simplification, but I will leave that as an exercise to the viewer. I'll leave that for you. This is not the final form we need for the lab, and it looks like, based on later questions, you'll have to do this one more time with slightly different variables. So let's think about what this would mean for a second. So I have the solution for delta t, and it's v initial of cart 1 plus or minus something. This plus or minus means that effectively we will have two solutions. Depending on these variables, we might have two valid solutions to this. So there might be 2 points in time where these carts pass one another. So I'll leave that to you to figure out.